Hi everybody, this is Phil Kerner, the Tool and Die Guy, and welcome to lesson number 282, working with triangular shaped parts. So this came across my bench just the other day, and this is a pretty rough looking piece here. It's actually been burned out on our plasma machine at work, and what we need to do is square up this triangle. And what I mean by that, we've got to make these two edges 90 degrees from each other, then machine this face. So let's look at a simple part drawing here. They gave me this dimension across the overall height here, and also an overall width along this surface of 6.344. So the first thing I did was I scaled this 3.172. That would determine how much I could take off of these sides and not lose my distance from here to here. So that was at about 3,350, so I had plenty of stock, and they're almost 200 thousandths. So I knew I'd be fine to just skim 20 thousandths or so off each side to get rid of the burn marks. Now, the question is, how are we going to do that? The first thing I thought about, well, I could clamp this to a machine table here, and then walk down here and walk down here with the side of an end mill. Two things I don't like about that option. It's not a horrible option, but whenever I can get away with not using clamps and use my vise instead, it's faster, I believe. And whenever I can use the bottom of a fly mill or a carbide inserted mill versus the side of an end mill, I think that's faster too. So here's my solution. This is a set of jaws, and I think I've shown you these before. It's a pair of soft jaws, repurposed. Obviously, they're made originally to hold a couple round parts in, but what I like about them is they're 4 inches tall. So what I did a few years ago is I took and drove in some dowel pins that are in line with each other, and then I've got another dowel pin here I can use as a stop if I'm doing multiple parts. So what happens then is what I'm going to do is there's two of these jaws. The mating jaw does not have these pins, of course, but it's the same height. And then what we can do next is simply mount this into the Kurt vise or your machine vise and push it up against the two pins, mill this side, the top. Now we've established that, then reverse the order, put the side you just milled up against the two pins again, and mill that side. So what we're going to do there is just skim these two sides in so we have 90 degrees. The next thing we're going to need to complete this project is one of my little angle blocks. And again, if you've watched my videos, I have a whole set of these. And this is going to come in very handy for two purposes in this video. As you can see, this is how I'm going to check it when it's done. I'm going to have a height from here to here, and I'm going to check it and just add the distance from here to here onto that. The question is, when we go back to my block, I made these, I think in 1980, and I never really figured out what it is from a theoretical sharp of the intersection of these two, of this 45-degree angle where they meet, what it is from there to here. So I need to know that dimension. So, this was a simple part, but all of a sudden I thought, to do it right, let's just figure it out. So what I did was I took my magnetic squaring fixture, and this is just an inspection magnet. I love this thing. It's a Brown & Sharpe. I bought it on eBay. I think they list for about $250, $300 new. Picked it up on eBay for about $60. I use it a lot. So now what I've done is I've put my angle block up against the magnet and put this is a 5/16 ball, and the magnet keeps everything from falling out. If you've ever worked with ball bearings, they really like to roll around. So now the magnet just keeps everything nice and tidy and even, okay? So then I bring down my digital height gauge and I touch the top of that ball, and from the surface of my surface plate here to the top of that 5/16 diameter ball, I've got a dimension of 705 thousandths. So at that point, now we're just going to do a simple math problem, a little ball dimension here. You can do it easily on AutoCAD, which I tend to do a lot more of these days. For you guys who want to know how I did it, there's the triangle you need to figure out. Not too hard. And just do some math, and you add on half your ball, and boom, boom, boom. So there's a 705 dimension I got from my digital height gauge. Doing the math down with my 112 thousandths and a half ball bearing, I've got a dimension of 327.8. So now 327 thousandths and 8 tenths. So now, just for demonstration purposes, this blue area is that part laid in there with the 3.172 overall dimension plus this dimension gets us almost 3.500, and we're going to call it close enough. Okay, 3 inches, 499 thousandths, and 8 tenths. So now I know that when I set this into my vise and take a skim off it, I can bring it back out to the next operation or inspection and check it. And there you go. I took it out once after I skimmed it, got a dimension, then came right down to finish, and I finished right at 3.500. So that was the first set of operations, just to make the triangle. Final operation is to drill the hole. And once again, back to my little soft jaws. This is a set I have that just has a 45-degree milled into it. And it's obviously I went straight through, so there's no stopping here. There's nothing to get caught on the corner. My part can easily go right through this V, and you see some holes in here and some mill marks. That's why you make soft jaws. Occasionally I have to drop this level and take a little bit off of here, but they're just two pieces of cold roll, and it's totally fine to drill into them. That's one of the beautiful parts about using soft jaws. So now when we mount these in the machine, it is a set. I put you'll see M and F fixed and movable. My apprentice put these in for me, so I want to make sure I put them in right. I turn this one around, and you'll see why in a second. And here's the other V block that's set into the movable jaw. Now let's see what the part looks like once we set it in. And there you can see why I turned this front jaw around. I wanted as much bearing as I could on this face. And there's my movable jaw holding this very nicely in place. I didn't even have to put any parallels under it. This is good enough. We're going to drill a 1-inch hole here, so no big deal. And then in case you didn't know, how am I going to find the center from here to here to locate that hole? Well, let me show you how I did that. Just pick a spot on the 45-degree angle and touch it with your edge finder. And what you're going to do there is set a 0 on in this case, my x-axis. Then simply pick up the edge finder, come straight across. Do not move it in this direction at all. And what you're theoretically doing now is hitting the same location on the angle, just on the opposite side. After you touch the second side, take a look at your readout. And it's 4 inches 511. So all I need to do is divide that number by 2. 4 inches 511 thousandths divided by 2. Move back that amount, as you can see. That looks like we're on center. And then obviously for the y-axis, all we need to do is edge find that front edge. And we're done. There's your hole. Okay, so there's a couple things going on for a very simple part. I used 2 sets of jaws, and actually had to use some trig and a ball dimension to really get this right. This is just a gusset. It didn't have to be perfect, but what we've solved here once and for all, for the rest of my life, I will know what the distance is on my little 45-degree parallel, what it is from theoretical point at the bottom to here. That's going to be a good number to know, and I'll write that down in my notebook at my bench. So I hope that explains some things to you. If you have any questions under the post, just make sure you comment or email me directly, and I'll be glad to answer them. So we will see you on the next video.